The concept of net present value, or NPV, is considered in an associated presentation. Here we're going to look at the internal rate of return, or IRR, of a project, and this uses the concept of net present value. But it turns the calculation on its head. Instead of deciding a discount rate and applying the appropriate discount factors to project cash flows to produce a net present value, the IRR considers what discount rate would be needed to produce an NPV of 0 for the project. So all competing projects or investments have an NPV of 0. However, they will all have different IRRs, representing the discount rate that was required to produce that value of 0. Consider the following cash flows of an investment. Here you can see year 0, 1, 2, 3, 4 and 5 with the costs, the benefits, and then the benefits minus costs. What we now have to do is to construct a spreadsheet to identify what discount rate leads to a net present value of 0 for this project. After some experimentation, we find that it is 6%, and you can see that here. For instance, in year 1, the benefits minus costs is 98. These are discounted by multiplying by 0.943 to give a present value of 92.42. And at the end of all of this, the net present value is 0. So the discount rate that produces a net present value of 0 is also known as the internal rate of return, and in this case, the IRR is 6%. The IRR allows the rate of return of projects of different absolute sizes to be compared directly, because the value of the IRR is a percentage. However, this means that projects may be selected that do not return the most money in absolute terms. There is also a technical problem with the IRR in that if the cash flow pattern is non-conventional, for example there is a negative cash flow followed by a positive one, followed by another negative one, then there may be more than one IRR, making it impossible to apply the technique effectively.